if you can recall our lecture on Reynolds transport theorem. Now, Reynolds transport theorem relates the control mass property to control volume property, system to control volume. So, Reynolds transport theorem states that a rate of change of any property for system, rate of change of any property. So, here we are talking about the momentum. So, rate of change of momentum for the system is equal to rate of change of momentum for control volume plus momentum going out minus momentum going in. So, with the help of this Reynolds transport theorem, which relates system property to control volume property, we can find out the momentum equation, and we can apply the momentum equation for this control volume A, B, C, D, E, F, G, H, A, right. So, momentum theorem states that force acting in x direction, because here we are concentrated only in x direction, force acting in x direction is equal to rate of change of momentum in x direction, which is equal to rate of change of momentum of control volume plus momentum going outside the control volume minus momentum going inside the control volume. So, what is the net force acting in x direction? At this point we have a pressure, let us say, is equal to P1. So, P1 multiplied by corresponding area. So, P1 multiplied by area, and then we have this area, projected area. If we see here, then in a cross section, this is area A, then here we have another area where corresponding to D basically and corresponding to G, right. So, we have little bigger circle, right, and this area corresponding to this diameter D2 is equal to, say, A2. Then P, and if we assume that pressure acting on this surface, wherever we have the surface, that surface will be exposed to some pressure. So, this surface is exposed to pressure, let us say P dash. P dash multiplied by corresponding area, and this P dash is acting on which area? A2 minus this area. So, minus area of this diameter, which is equal to A1. So, A2 minus A1. This pressure force is acting in x direction, and on this face EF, the pressure, this is the velocity is shown with the help of these arrows, pressure is acting in such a manner so that it compresses the fluid. So, pressure always acts, if magnitude of pressure is P2 at this face EF, then this pressure will act in this direction, which compresses the fluid, right. So, we have a pressure P2 into A2, since this is acting in which direction? Negative x direction, this is negative x direction. So, this is minus P2 into A2. So, this one on the left hand side of this equation is the force acting in x direction. Now, force acting in x direction, as per our momentum equation, force acting in x direction is equal to rate of change of momentum in that direction for this control volume, right. For the control volume we have this equation as per the Reynolds transport theorem. Since flow is a steady flow, so dm over dt, this term becomes 0. Flow is a steady flow, so rate of change of momentum for control volume is 0 plus momentum going outside the control volume. What is momentum going outside the control volume? It is, since flow is a steady, so q multiplied by rho multiplied by velocity. Rho q multiplied by velocity is the momentum going outside the control volume in per unit time. So, rho q multiplied by V2, since rho q is a constant here, flow is a steady flow. So, that is why rho q is taken outside this bracket, and momentum going outside V2 minus momentum going inside is rho q V1, rho q is taken outside, rho q V2 minus V1, right. So, with the help of Reynolds transport theorem we can apply the momentum equation for this control volume. and left hand side we have a force in x direction, on the right hand side we have momentum going outside the control volume minus momentum going inside the control volume plus rate of change of momentum in the control volume, and rate of change of momentum in the control volume is 0 because flow is a steady flow. So we have only left with these two terms, which is momentum going outside the control volume minus momentum going inside the control volume. Now experimentally it was observed that this P dash which is being applied here on this surface is equal to P1, right. So then we will solve this equation, and algebraically we can get P2 minus P1 into area is equal to rho q V1 minus V2. And we all know with the help of continuity equation that Q is equal to V2A2 is equal to V1A1. So further we can manipulate this equation. P2 minus P1 is equal to rho q, q is equal to V2A2 or V1A1. So you can select any one. Here we have selected rho V2, right. So V2, and since here we had selected A2, this was A2 here, so it is better to select this V2A2. Otherwise we can select anything. We can select V1A1, we can select V2A2. If we select V2A2, this A2A2 is cancelled and this will become rho V2 V1 minus V2, right. So with the help of continuity equation we can simplify the momentum equation for the control volume, and this is our equation number 1 say. Now our aim is to find out head loss due to this process. Now in this term we have not come across with that term in which we are interested. So let us apply another equation, another governing principle, that is Bernoulli equation between AB and EF. AB means at section 1 let us say and section 2. Entry of the control volume and exit of the control volume. So let us apply the Bernoulli equation. So this was based on the momentum equation. This equation which we are going to write, it is based on the Bernoulli equation between point 1 and point 2, or section 1 at 1 and 2. So what is Bernoulli equation? Total energy at section 1 is equal to total energy at section 2. So P1 over rho plus V1 square divided by 2. This is the total energy per unit weight at section 1, plus that, since it is a horizontally situated, so we are neglecting that, is equal to, what is the pressure available at point 2? It is P2 divided by rho plus V2, if velocity is, since area is different, so here we will have different velocity, V2 square divided by 2 plus some energy is lost. So some energy is lost, so we have GHL, right. Generally P1 over rho g plus V1 square divided by 2g is equal to P2 divided by rho g plus V2 square divided by 2g plus HL. It is written like this, so we have multiplied it by g, so we have this equation.